Okay guys, here I am again, and just want to show you once more. I have the terminal clamp between the output post, and this is ground here, and I am on the ohm scale. And as you can see here, there is no resistance whatsoever to ground, so it's going from straight positive straight to ground with some heavy duty gauge wires. And it took me a while to do the engine swap with work and all, so it's it could have gotten internal corrosion and it could have grown, whatever the theory is, whatever. Point is, there you go, see that, boom boom, and then boom, just straight to ground. So what I did is, you saw in my earlier video, this 120 fuse was blown. I separated the two terminals even further, and I stuffed 80, I don't know if you could see that, it's a 80, it's a spare fuse I had laying around that I figured, hey, what the heck, I'll just use it. A lot of people won't agree with me, but I don't care, because this fuse is gonna be replaced anyway. So I just want to show you guys a known good alternator. There you go. Okay, you see with these two separated, it says OLM ohms. Okay, so now, here we go. Let's stuff my terminal down in here. Switch this to voltage just to check the ground. Touch this to here. And there we go. We got 12.61 volts. Okay. There's nothing wrong with this engine. So now I'm going to go back to ohm setting. Touch the post. Okay. What do we have here? No. It's auto ranging. So there we go. Auto limit. This is a known good alternator, by the way. I know, or I am also aware of different designs, but if there is going to be a different design, there should at least be some internal resistance in the alternator. So you see that? With that, we know that ground is good, and I'm touching this terminal. It's isolated, nothing's plugged in. You see that? So, out of limit. That's what it should read on a good alternator. This should not be shorted to ground, of course. So, as we saw, the other one is bad. Now, with my Hyundai here, I'm going to be replacing the fuse. So I cracked open this the little glass screen, separated the fuse, and I'm going to hook up the battery now. And I already know it's not going to blow based on my test. There is no short to ground on the wire leading to the alternator, and I just showed you with the ohm test there's no resistance or separation of the post to ground. So that's what's bringing my entire circuit to ground. So here, I'll put the battery back in. Okay, now remember, this is what happened when I touched it. It was shorted. It was pulling a crap ton of amps to ground straight from battery positive. And here we go, you guys. I'm gonna do it again just to show you that there are no sparks or anything with that alternator disconnected. I haven't touched it, so I don't know what's gonna happen. Look at that. There we go, perfect. It's coming to life. See that? Fuse didn't blow. This is a lower fuse. This is an 80 amp fuse stuffed into a 120 amp fuse. So here we go again. Let's see if you can hear something. There we go. I can hear something happening. There's some sounds like the fan inside is turned on. Let me go check. It sounds like the fan that's inside is turning on as soon as I turn this on. And yeah, see that? It's on 4. So, there we go. Now, I promise you that I didn't do anything. And I'm going to try to turn on the headlights, actually, just to watch you, or just to show you that now the current's working and it's not exploding to ground. Oh, wait. There we go. See that? Beautiful. Shorted internal. An internal short to the alternator was a problem. Crazy.